Assalamualaikum and hello everyone. Today we are going to present our aerospace machining project, which is the aircraft ribs. This is our group members. First, AFIQ SYAMEL bin ZAINALABIDin. Next, Muhammad KAMIRUL NAIM bin SUARDI. For the introduction, the main objective of this project is to design, manufacture and inspect the aerospace part. As we all know, aerospace components often have a complex geometries and usually made from advanced materials such as aluminium, titanium, superalloy and composite, which are difficult to be machined. In other words, CNC machining aerospace parts are complex, and aerospace industry required that dimension, tolerance and performance are the tightest and the highest possible for every part. The design of our product is the aircraft rib, which is the forming element of the structure of a wing. By analogy with the anatomical definition of ribs, the rib attached to the main spar and by being repeated at frequent interval from a skeletal shape for the wing. Usually, rib incorporate the airfoil shape of the wing and the skin adopt this shape when stretched over the rib. The design is simple, but the machining process is quite challenging due to its tolerance and size. Next, for the machining operation of this particular part, we use several cutting tools, which is the face mill diameter 63, end mill diameter 10, end mill diameter 6, end mill diameter 2, and ball mill diameter 6 with radius 3. For the machining process, we use the facing process, roughing process, pocketing process, and profile contouring process. Next, for the facing process, first select that part of the product and select the safety plate. Ensure all the parts turn green and set the offset on check and offset on top to 0 mm. For the machining strategy, set the tool path style to one way and set the end of the path to out. For the macro management, active the approach, retract, return in level retract, return in a level approach, return between level retract, and return between level approach. Moving on to the roughing process, first select the part of the product, select the rough stock, safety plane, top and bottom of the product. Then set the offset on part and set offset on check to 0.5 mm. For the machining strategy, set the machining mode to by area and outer part and pocket, and set the machining tolerance to 0.1 mm. This is the tool path for the roughing process. Next, for the pocketing process, first select the part that need to be pocketed and ensure all the part turns green. Set the offset on check and offset on top to 0 mm. For the machining strategy, set the tool path style to outward helical and set the machining tolerance to 0.1 mm. For the macro management, active the approach, retract, return in a level retract, return in a level approach, return between level retract, and return between level approach. Add the helical motion and set the macro ramping angle to 3 degrees. Then select the feed rate to the machining. For the profile contouring process, set the part that need to be done and ensure all the part turns green. Turn the stop and start to out. For the machining strategy, set the tool path style to one way and set the machining tolerance to 0.1 mm. Also for the step over, change the distance between path to 2 mm and the number of paths to 1. Also for the axial strategy, change the maximum depth of cut to 1.25 mm. For the macro management, active the approach, retract, return in a level retract, return in a level approach, return between level retract, and return between level approach. So this is the tool path of the profile contouring process. Next, we are going to show you the full simulation of our machining process. For the first process is the facing process, and then moving to the roughing process. And next we have a pocketing process, and then the profile contouring process. And for the last process is the profile contouring process. We're using the anvil diameter tool. So this is the end of our product. Next, moving on to the result and discussion. After we finish our machining process, we found out that our part left the cutter mark. The cutting mark is caused by the unsuitable usage of cutting tools, and other than that, improper setting of feed rate is also one of the main reasons. Next, we also found out that the surface of our product leaf step, which is the presence of step, is due to the round machining style, which is the step over amount between the cutting pass. This kind of problem can potentially be exacerbated by the usage of incorrect cutting tools. Next, for the conclusion, we can conclude that this particular project is successful. Throughout this project, we can improve and expose ourselves on using CATIA. In addition, the objective of this project clearly gives a big impact on us so that we can produce the component or part using CATIA efficiently. By doing so, it will also provide the opportunity to capitalize our technical skills and abilities in the field of industrial or manufacturing engineering. We hope that the aerospace industry will grow bigger and indirectly offer a lot of job opportunities. Next, these are some attachments from our project, which is the first is the clamping process. As you can see, we clamp the piece onto the machine, and this is a process where we set the datum. And then this is the machining process, several machining process, which is the first one is the facing process, and then we can see the roughing process, and this is the end of our product. So that's all from us. Thank you and see you again.